This particular series is part of our Programmer to Programmer series. This is our free training that we offer people. So we offer a mix of free training and paid training. The free training is to try to make, you know, professional level content available to everybody out there who would like to make use of it without having to be an employee of a large corporation or without having to sign up for a professional programming class. It's a great way for us to explore different technologies in a little bit less stressful kind of environment and to explore some of these things to see how they work. So our goal here with this programmer to programmer training is A, high quality training, deliver the training in such a way that anybody can access it with a web browser and an internet connection. As part of that, we'll be using GitHub code spaces today to do all of our Rust development and Leptos development. Focusing in on in-demand languages and frameworks so you can get a high-paying job today. Empower people to work where they live, right? People travel all over the world for various reasons, but I know myself ever since COVID, I've been working from home, and I enjoy working from home, working in my local community and not having to travel all over the place. So our goal here is to help empower people to do that so they can be successful where they are and not always have to relocate or travel a lot. And then, of course, employ some AI tools to enrich the human experience of programming computers. We'll take a little bit of a look at Copilot and stuff today, but with Leptos being so new, generative AI isn't quite as helpful in working with it, but we'll see a little bit of that being used in the course of today. We would love for you to connect with us. There's our website there, www.trainingforprogrammers.com. You'll see upcoming trainings and stuff that we have. You'll also see links to videos for previous trainings where we actually did have a video to share, stuff like that. You can also reach out to us on LinkedIn. We always love having people follow us on LinkedIn. LinkedIn is one of the biggest ways that we promote events. So if you follow Training for Programmers on LinkedIn, you'll be sure to be notified of those events. We also publish videos up to YouTube. We always publish the recordings up to YouTube. Sometimes I also create some shorter videos from those. Just depends upon the amount of time that I have or don't have. But you can check out our YouTube channel there. And of course, there's our email address if you want to reach out to us with anything. One thing I do want to mention before we get any further into this is I'm going to put a link here in the chat. We also have a Discord group. The Discord group is also another place where I post occasional content pieces. I post up and coming events. I ask people if they'd like an event on something. For example, our next programmer to programmer event is going to be on extending Python with Rust. So we're going to write Python extensions in Rust. I reached out to the people on the Discord group, and people seem to be interested in that as a topic. So we're going to do that on Friday, July 19th at 9 a.m. It's only going to be a 2-hour session. It's not a full day, but it's a little longer than a regular webinar. And so we're going to do that for 2 hours on Friday, July 19th. If you want to sign up for that, just simply go to trainingforprogrammers.com and you'll see the link there to register. You have to scroll down a little bit, but you'll see the link there to register. We are going to go ahead and offer our first professional class. Now, technically, we originally were going to offer the Leptos class as our first professional class, but I had a lot of things going on back in April and I actually had to cancel it. And we rescheduled it for today for free for everyone. But we are going to be offering a class on doing data frames with polars. So polars is kind of like pandas, but for Rust. So if you're familiar with pandas in Python, polars is like pandas, but it's for Rust. And it actually allows you to use it both with Rust and Python. So we'll be looking at using polars with both Rust and Python. So if you're looking to get into doing Rust programming and you want to leverage that speed of Rust and you actually want to write your program in Rust, then Python pandas won't do you much good. But you can use polars to do your programming that way. So we'll be offering that as a 2-day class. That'll be August 1st and 2nd. I believe it's a Thursday and a Friday. Each day will be 7 hours in length, and the price for that's going to be $950. It's a professional class, so it costs a fair amount, but it'll be a great session on working with pollers for those 2 days. If you go to the Training for Programmers website, you'll see the link there at the top to register for the class if you have an interest in doing so. All right, so here's our kind of our agenda for today. Our class day is going to go from 9 to 3. We're basically going to do like an hour and 15 minutes of teaching. Then we'll take a 15-minute break. Then we'll do another hour and 15 minutes. We'll take a short 30-minute lunch. Then another hour and 15, another break, and then a final session until 3 p.m. Eastern time. Essentially, we're just going to be learning about Leptos and, of course, improving our Rust skills along the way. We'll start off with kind of what is Leptos, creating a project and configuration. We'll take a look at working with views and signals and connecting to a data source. I teach a lot of Angular and React in addition, and Blazor from the C# world. Those are all component-based UI frameworks and libraries. I'll be relating some of my knowledge of those here to Leptos, and I'll be offering kind of my opinion on Leptos, what I like, what I don't like, how it relates to things, how it relates to these other UI frameworks and libraries as we go along kind of throughout the class. Okay, before we jump into the content, a couple of things here real quick. First of all, thank you for registering and attending. After the session is over, go back and watch the recording again. Go back and practice some of the demos that we do. If you've got questions on anything that we covered in the class that you just didn't get to ask during the course, you can go to Discord, and I put the link to Discord in the chat, and you can ask questions over there. Within 72 hours of the event, I will send out the official recording, a link to the repo, and the badge. So if you signed up for the class and you're here today, you'll get a badge for attending. Follow us on LinkedIn. In fact, I actually need to remove this because I'm going to stop using Eventbrite. So this was the last session where you would register through Eventbrite. So you can follow us on Eventbrite if you'd like, but we're not going to be doing anything else on Eventbrite. But it's all going to be on. Follow us on LinkedIn and you'll get updates on all the stuff. At the end, I'm going to give you a link to an evaluation for you to fill out. The survey is a great way for us to get feedback on what we can do better, new topics for the future, stuff like that. So probably at the afternoon break, I'll give you the link to that. And if you could fill that out before you take off, it would be much appreciated. Okay, let's go ahead and jump into before we jump into the content, one other thing I want to mention. There is a chat and there is a Q&A. If you have a question on something regarding the content, what we're talking about, go ahead and put that question in the Q&A. The Q&A is where I'll be paying attention to questions coming in about the class. If you've got other chats you just want to chat with other people about, you can use the chat for that. But if you've got questions and stuff, go ahead and put it in the Q&A there. All right, so what is Rust? So Rust is a fast, memory-safe, and concurrent systems programming language, right? One of the big things we hear about today in the news is all of these different exploits that are found in software. Oh, yes, I can give you the link to the Discord again. Give me 1 second. Copy that. Thank you for asking. And let me drop that in the chat again. There you go. So just check the chat for the Discord link. In fact, I could probably reply to it right there. Perfect. I apologize. This is my first time using Teams for webinars, so I'm still getting the lay of the land here as far as Teams works as a webinar tool. Okay. So as you all know, there's been a lot of cyber exploits of software because of memory issues. Rust basically forces us to program in a memory safe kind of way. Probably, in my opinion, the number one biggest benefit of Rust is it really forces you to think about how memory is being used. Even if you end up not programming things in Rust, you go back to other languages or what have you, the process of just learning Rust will really cause you to think about how you're accessing memory. And it will help you actually do that better in other programming languages, in my opinion. To help you with this, essentially what Rust does is it moves memory management from runtime back to the compiler. So if you think about like a garbage collected language, all a garbage collected language does is it makes your application memory safe at runtime. So when you stop using something in memory, it cleans it up for you. Well, what Rust is doing is basically taking that same concept, but enforcing it at compile time when you compile your code. It's ensuring that you're working with things in a memory safe way and takes care of kind of cleaning things up for you based upon the compiled code. And so instead of having everything kind of figured out at runtime, we're figuring out our memory safety at compile time. It provides powerful type safety and error handling. One of the cool things I like about Rust is that errors are treated as values, which is a very powerful thing. It can be a little bit difficult to become an expert at when working with Rust, but it really does I think give you a much cleaner way of handling errors in your code, especially when you start bringing in things like the question mark syntax and libraries like anyhow or crates like anyhow. Zero cost abstractions. So Rust basically gives you a bunch of high level features without a lot of the runtime performance penalties that you get in other languages by giving you these zero cost abstractions, which are all resolved at compile time. You can use Rust for a wide range of applications. People refer to Rust as a systems language, and it is. You can definitely program things to work at a low level in the system, but you can use Rust to create web applications, to create REST APIs, to build little utilities. Sometimes people are a little surprised to hear me say this, but I'll use Rust as an alternative to Python when just writing some basic, I don't want to say scripts because Python's or Rust is not a scripting language, but something that I might write as a script in Python, I'll write as a small little console application in Rust. And I have actually found it to be much more versatile and even much easier to use than I originally expected. Don't get me wrong, there's definitely a learning curve and it can be challenging. But once you start to kind of get how Rust works, it's actually pretty enjoyable to work with. So what is Leptos? So Leptos is just basically a web framework for Rust. It allows you to build full stack applications. Now, most of our time today is going to be focused in on the client side of things, but you can do full-blown full stack applications with a REST API in the back end and a client-side code on the front end, and it's got a bunch of cool ways for integrating those things together. So you can do server rendering, you can do client-side rendering. For the client-side code, it uses a component-based model for building things, just like you would have in React or Angular. It uses technologies like signals, like you'll find in some of the more modern JavaScript frameworks for reactively updating the UI when your state changes. It's pretty cool, actually. You can get up and running with a little bit of tooling and some minimal configuration. It does make managing state a little bit easier in terms of working with the reactive signals. And it kind of does so in a way where you don't have to fight the borrow checker quite as much. That being said, you still have to know how to manage memory in Rust. When we say easily managed state, I don't want you to think that all the complexities of Rust have gone away. That is not the case at all. In fact, when working with Leptos, one of the biggest challenges you will deal with is just your knowledge and experience with the Rust programming language. Write server functions that work across both the server and the client. We'll take a look at those. And sleep well knowing that Rust type safety is protecting your whole app. These bullet points here are actually from the Leptos website. I will say when I build things with Rust, I do feel more comfortable that my code is actually working correctly. Like it's actually going to work in production. In languages like a Python or a JavaScript, because everything is so dynamic, bugs and errors, unexpected things can happen at runtime because of the dynamic nature of the language. With Rust, I feel more secure about that. And if I'm using Rust to build the Leptos app, then it gives me a little more security about the web application that I'm working on. Okay. Let's go ahead and get started doing some programming here. Now, we're going to try to keep our setup here as easy as we can. So number one, if you just want to watch us do the live coding and demoing, that is perfectly fine. If you do not want to code along, just sit back and watch and enjoy the show for the next 6 hours. If you would like to code along with me, I have set this up so that everybody who wants to code along should be able to. There are 2 requirements, though, in order for you to code along. Number one, you will need a public GitHub account. So I sent out in one of the emails this morning to make sure you're logged into GitHub. So if you're not logged into GitHub with your personal account, go ahead and do that here real quick. And then after you're logged into GitHub with your personal account, you can use GitHub Codespaces to do the programming. In fact, I'll be using GitHub Codespaces as well. Now, I am assuming that everybody has plenty of free credits to use Codespaces. If you've used up all of your Codespace credits, then using Codespace is going to cost you money. That's not something that we're paying for or offering to pay for. GitHub's not going to pay for it. If you still have your free credits, and I think you get like 120 hours a month of free credits or something like that. If you have free credits, then you should be able to create the Codespace and do all of that for free over the course of our 6 hours today. The one thing that I will mention is that when we do work with Leptos tends to need a little bit more power to get everything compiled up. So you'll notice here on my dev container file, this is the file that tells GitHub what type of code space we need. I've actually had to increase the requirements a little bit on it, so it does eat up those free credits a little bit faster. But in order to do all the compiling and stuff that we're going to need to be doing throughout the entire class, having a little bit more powerful code space environment makes a lot of sense. So anyways, if you're logged into GitHub and you either have free credits or you're willing to pay for the code space, I would invite you to do the following. I'm going to put the link to the repository in the chat. And what I would like you to do is to fork the repository. Okay, so come over here and click fork. And then after you fork the repository, okay, then create the code space off the fork. Don't create the code space off of my repository. You won't be able to save any of your changes. But if you fork the repository, then create the code space off the fork, then you'll be able to make your changes and commit them back to your fork. All the coding that I'm going to be doing, I'll be committing that code to the repository to the repository here as we go through and do all the programming. Okay. All right, so I'm going to give you about a minute or so to log into GitHub, make a fork of the repo, and create your code space. So we got about a minute here. We'll just kind of be quiet here for a moment. Let everybody do that who'd like to do it. Let me check out our questions here. You are more than welcome to clone it and run stuff locally if you'd like. If you already have Rust set up, the only challenge you're going to run into is there's a number of things that have to be installed. In fact, If you want to do that, let me give you this. That's a great question, by the way. So I have in this repository, which I'll share with the class. In this repository, I have my dev container images that I create, and I have one called Rust Leptos. If you click on this and view the Docker file, it'll show you all of the Debian packages I installed on Ubuntu, but it'll also show you the how I have Rust configured and the various extra packages that I installed using Cargo. So these here are like these are command line tools. Okay, these are tools that we're using to do our Rust programming. So if you're going to set up a local environment, you'll need to make sure that you install all of these tools. Also, make sure that you are using the nightly version of Rust. And I'll give you a direct link to this if you'd like to view that Docker file directly. Okay. One last thing I'll mention while people are setting themselves up. If you go under dev container here and you see Docker file, this is the image that I use to create the dev containers. If you want to run your dev container locally and all of that, you can also do that as well, and you don't have to set up everything. But you're always welcome to pull down these images that we have up on Docker Hub. If you're looking to have like a ready to go environment for Rust, Python, stuff like that. As you can see here, we have a number of images that are ready to go that you can then utilize for local development in a dev container or something like that. All right. So we'll go ahead and let me restart the code space here. And we'll go ahead and jump into this. Now, if anyone is having any setup issues or other problems, I'm truly sorry. There's not really anything I can do in this short class to be able to help with a bunch of individual configuration issues. If you can't get it working, just sit back and watch, and then later on when the session is over, you can go back and watch the recording and try walking through it all again on your own. And of course, once the session is over, you can always ask questions on Discord about setup and things like that if that's helpful to you. All right, so with that said, let's go ahead and take a quick look here at our structure for our project. So we've already looked at the dev container. The VS Code just has some configuration stuff. Inside the code folder, I have a CSS file that we're going to be using to do our programming. So we'll be copying and pasting that over to our new project here in a few moments. I have a docs folder here, and the docs folder basically has instructions for how we set up our SQLite database. It also has some instructions for creating our project that we're going to be working through. Please do not attempt any of these instructions quite yet. We'll take a look at how to walk through these here in a few moments. Inside of our projects folder, this is the final version of what we're going to be building. We're going to be creating another project in this folder, which is going to be the thing that we're live coding during our session here together today. As you go down, you'll see we have a cargo toml file. This is the cargo toml file for the overall workspace that we're working in. Okay. The reason why I mentioned that is each individual project in here will also have its own cargo toml file. So this is the root one. This is the one for the local project. Just don't get confused by them. We have one at the workspace level, which lists all the projects. We'll have each project itself will then have its own cargo toml file. Last thing I'll mention here is this Leptos format toml file. So one of the cool things about working with Leptos is it has a view macro, and that view macro is how we build our HTML views inside of our Rust code. This Leptos format toml is basically controlling how we format the code inside that view macro. You don't have to have this, but I do have it here as part of our configuration for our project. Over here in the code space, we have a number of extensions installed, all the standard stuff that you'd have for Rust. There is a Leptos extension called Leptos VS Code. I installed it a few days ago, and I've been kind of playing around with it. I haven't really tried it out too much to see what it really does for me or doesn't do for me. But I wanted to mention that if you search on Leptos, you will find this extension over here. I'm not going to install it, but if you want to check out extensions, there's 2 of them that pop up when you do a search inside of VS Code. Okay, so with that said, what I'd like us to do to get started is let's open a terminal window. So inside of code spaces, if you want to open a terminal window, you can click on the three line menu over here. Go down to terminal, click on new terminal. So if you click on the little sandwich menu, terminal, new terminal. And then what I'm going to do is I'm going to change into the projects folder. So go ahead and change into the projects folder for me, please. Okay. Once you're in the projects folder, we're going to create our initial Leptos application. We're going to use a starter project provided by Leptos. This is really the easiest way to get up and running. So what I'm going to do is I'm going to copy the command. In fact, if you were to go to this page right here, this is where the command is. I'll drop that direct link in. So the command is right here. Once you're inside the projects folder, we're going to copy this command, and we're going to come back over to our terminal window, and we're going to paste that command into here like this. So we'll say cargo leptos new -- get, and it's going to pull the starter project from the leptos -rs start. And if we hit enter here, it's going to prompt you for a project name. I'd like you to call the project name Tools App. So Tools App final is the completed one, but Tools App will be the one that we're going to be creating together. So project name Tools App, hit enter. It'll ask you if you want to use nightly features. Go ahead and say yes. And then it should create a Tools App folder here for you like this. I'll pause for a second while you do that. You can also see the instructions listed there in that document if you'd like. Now, as part of creating this project, it should automatically add to the root level cargo toml file. It should add this. Actually, you know what? With Leptos, it doesn't. If you use cargo new or cargo init for a project, it does add it automatically. But with the Leptos mechanism here for creating the project, it actually does not add it. We'll need to add it manually. So go ahead and add Tools App to our project list in that root cargo toml file. So if you look at the cargo toml file right next to the Leptos format, add our project path to that, and that will incorporate Tools App into our overall cargo workspace. I'll pause for a second while you do that. Now, ordinarily, if you were just creating a single project, you wouldn't have to add this to a workspace, but because we have a workspace with multiple projects, that's why we have this extra step that we have to do. Okay. All right, now that we've got our project added, now what I'd like you to do is change into Tools app. So you should now be in the Tools app folder, not Tools app final, but the Tools app folder. So we're inside of Tools app. It'll look like this for your content. Now, we want to run our Leptos application. There are two ways of doing this. You can say cargo Leptos watch. And what that will do is that will actually run the application in watch mode. And as you change your files, it will do the whole hot reloading thing, kind of like what you'd see in an Angular app or React app, what have you. I'm going to run this one time just so you see what it looks like, but I'll be honest with you, I don't use Cargo Leptos Watch. It does not work that great. I find that it doesn't always recompile things. It doesn't always reload things like I would want. It's not as reliable as something like the Angular CLI or using something like Vite or whatever in the JavaScript world. It just doesn't work that well. So we're going to run it. You can see what it looks like when it runs. It's going to do the whole build mechanism here. And then it'll fire up the website. But then what we're going to do is we're going to stop it. And I'm going to show you the way that I actually do my Leptos development, which I have found to be far better, far better. See the compilation? If you had to ask me what's probably the one downside to using Leptos over other UI frameworks and libraries in other languages, is that it is a little bit slower because of the compilation. Even I do a lot of .NET development too, client-side stuff with Blazor, and that's way faster than even this is. So Rust's reputation for being slow to compile, it does make things a little bit slower, especially if you're used to rapidly iterating on a client-side project. It does make things a little bit slower. Once you start this up, it'll offer you the option to open in browser. So if I click open in browser, it'll do the port forwarding for me. And you can see here's our Leptos application. So go ahead and run that and make sure you can load this up and do the click me. Okay, I'll give you a minute or two to let that finish compiling on your end and offer a couple of additional thoughts. So Leptos is not the only framework that requires itself to be compiled. All of the JavaScript ones get compiled now. If you're doing things with, let's say, Java or C#, it's compiled. Because Rust's compiler is slower than generally all of those, it can make the web development feel a little bit slow. One of the problems I have found, and in fact running this in watch mode, is that as you modify your code, it constantly wants to recompile itself, which is just slow. So I don't recommend that. What I do recommend is to do your development like this. So I'm going to hit Control-C to stop the server. What I do recommend is using cargo Leptos serve. What that will do is that will build it and serve it, but it doesn't watch. So you build it, you serve it, load the page up, try out your code. If there's a problem or you want to add more code or fix a bug, just go make your code change, then come back and stop the server and start it again. I know a lot of people don't like that process of having to stop and restart, but I find that that works much more reliably than using the watch and is a much better development experience. So for example, if I say cargo Leptos serve, it's up and running faster, but that's only because it was already compiled. So now if I say open in browser, it opens it up like it did before. If I then wanted to make some changes to a file, I'd open a file and make changes. Then when I'm done, I'd stop it, Control-C, and fire it back up again. That will be the process that I go through as we do the class here. So Leptos is awesome, Rust is awesome, but if I'm honest with you, the rapid iteration, the speed of development in terms of the compiles and getting the app, loaded up in the browser is slower than what you would find in other languages, not just compared to JavaScript, but also compared to things like C# and Blazor and stuff like that. Okay, so with that said, let's go ahead and take a look here at how this little hello world thing is even working. So if you go into Tools app and you go into source, you will find an app RS file. Now the app RS file is not the starting point of the application. The starting point of the application is the main file, but we'll come back to main a little bit later. Let's focus in on app RS and take a look at working with components here first. So first of all, this is the app component. This is the root component in the application. Okay. So if you've ever worked with a component tree before, you have that one component at the top of the tree and all of the other components come underneath of it. That's what this component is. You will notice that there is a macro applied here, component to the function. So this is going to basically, this is provided by Leptos, and this tells Leptos that this is in fact going to be a component that we can render in the UI. Now, we have another macro here called view. The view macro is where you're going to put all of your HTML and as well as your syntax for calling other custom components. If you've worked with JSX before in React, this is very similar to JSX. You'll notice that we have these capital letters for these custom components that we're calling, and then we have lowercase letters for the actual HTML elements that are being rendered. So if you're familiar with React and JSX, this works basically the same way. Okay, you'll feel very much at home. Obviously, none of this is valid Rust syntax. However, because Rust has this powerful macro system, the author of Leptos created this view macro, or at least somebody on the Leptos team created this view macro. And basically, it allows them to define kind of their own custom language and then transform that into valid Rust code, kind of like what the React team did with JSX. JSX is not valid JavaScript, but the transpiler converts the JSX into valid JavaScript code. Now, we scroll down here a little bit. You'll see that we have a reference to a homepage component, and this is the homepage component right here. So here we have homepage. We have a signal being used. Now, signals are not unique to Leptos. Signals are kind of the new cool way of managing application state in a lot of different UI frameworks and libraries out there. In the React world, create signal would be similar to use state. In Angular and Solid.js, I believe, and Svelte and all of that, they all now also use what are called signals. Same idea here. The basic thought process is I can read the value of count here, and I can use this to update the value of count. So the idea here basically is my view is going to read the value of count. That's basically going to register that this view needs to update whenever count changes, hence the reactivity. And then here on the set count, we're going to have a function that's assigned to the onClick. And when this function is invoked, it'll basically call dot update. It'll receive the current value of the count and then allow you to modify it. Now, don't get too distracted by all the Rust syntax yet. We'll go over a lot of it. But just for the time being, just understand that we've got the actual data. We have a function to update that data and trigger the re-render. We have a function where it uses the update function to modify the value. And then we have a view which displays the value and also provides a button to execute that function. So over here, when you click this, you'll see it is incrementing that value for us. Now, I'm going to open the DevTools here in our browser. And I'm going to reload this page from scratch. And let me pick all here so we can kind of see everything. So take a look at what was downloaded here. We started off with the actual HTML document, a CSS file, a JavaScript file, WASM, and the favicon. Now, the idea behind Leptos is that you are not writing JavaScript. You are writing Rust code. That Rust code can run on the server. That Rust code can also run directly in the web browser via WebAssembly. You see this tools app.wasm? This is your Rust program compiled to WebAssembly. So this is the actual Rust program being downloaded here. So the question then becomes, what is tools app.js all about? Here's the thing. When you use one of these WebAssembly frameworks, it could be Leptos with Rust. It could be Blazor with .NET. There is always some JavaScript that has to be provided by the framework. Why? WebAssembly is a runtime inside your web browser. You compile code for that runtime, it runs. The problem, though, is that WebAssembly does not have the ability to directly manipulate the DOM tree. In order for WebAssembly to directly manipulate the DOM tree, it has to go through JavaScript first, which means even for a WebAssembly app, there is always some JavaScript. But here's the key. When you work with things like a Leptos in Rust or a Blazor in C#, you don't have to write the JavaScript. The JavaScript is provided as part of the framework. So all we've done is create a Hello World app and reviewed some Rust code. But behind the scenes, there's a JavaScript file, which is handling a lot of the details for us for basically interfacing the Rust WebAssembly with the DOM tree and other services. So I mention that to say it's not that we are JavaScript free, it's that we are not writing any JavaScript. Now, is it possible to write some JavaScript code and interface that with your Leptos application? The answer is yes. We're not going to be doing that as part of today's session, but it is possible. Here's the thing, though. If you end up finding that you're using something like a Leptos or a Blazor, and you're writing lots and lots and lots and lots of JavaScript code, just go use a JavaScript framework. The reason for using Leptos is so we don't have to write JavaScript code. If we have to write a ton of JavaScript to do what we need, just use a JavaScript framework. But if you're looking to program in Rust, or in the case of Blazor with C#, and you're not going to be writing very much, if any, JavaScript code, then these frameworks are perfect to get you what you need in terms of building client-side applications in a really great memory-safe programming language. Okay, so there's our page there. When I click on this, you can see it increments. I want you to notice there's no additional network traffic. So we had network traffic on the initial load. I have it set to all, so it should be showing any network traffic that occurs. Notice that this is changing without any network activity. And that's because all of the Rust code that increments the counter is inside of the WebAssembly file, which is already downloaded into the browser. Now,
it is worth mentioning that the WebAssembly file can get large. In fact, let me disable cache and reload. This WebAssembly file is 4.1 megabytes in size, and all we are doing is click me. You can make that smaller when you do a production build of the application and apply things like Brotli and stuff for compression to the WASM file. But WebAssembly, probably the biggest drawback to it is that it can produce a very large WebAssembly file that basically downloads the whole program onto the client computer to run the application. Unfortunately, Leptos does not have a very good way of breaking this WebAssembly up into smaller pieces. Things like Blazor and C#, they have a number of techniques they use to really optimize what's being downloaded and downloading what you need when you need it. Leptos isn't quite that advanced yet. So if you do go with Leptos to build something, just be aware that while yes, the release build and yes, compression can make this much, much smaller, one big problem you will run into as the application grows in size is the WASM file can get large. Now, to help improve the initial loading performance, Leptos does support server-side rendering of the initial page load. So if you do a server-side render, it gets content up on the screen really fast for the user while that WASM file is kind of downloading. But just kind of keep that in mind that the WASM file can be quite large. Okay, so there we go. So there's our basic structure here of our component tree. There's also a not found component as well. Next step, let's take a quick look here at the main RS file. This is the main file that basically launches the whole program here. You'll see it fires off an HTTP server. It sets up our application. It binds to the address and port, and then runs the application, and then we are up and running. Okay. I'm not going to go over each of those things in detail. We're going to focus more in on building something that we can actually see and interact with. If we get to the data access part of the course, we will come back here and wire up some data access stuff. If we don't, it's already wired up in Tools App Final, and you can take a look at it there. All right, so with that said, let's go ahead and let's get started building our little application. So the first thing I'd like you to do is you'll notice here in Tools App, there's a style folder with a main SCSS file. You'll notice that file is basically empty. What I would like you to do is go under the code folder to the main SCSS file that looks like this, copy the whole thing, then head back over to the main SCSS inside of Tools App, and just copy and paste those styles over for me, please. And then we're going to use those styles as we build out our application. Okay. So with that said, we're going to get started first by building a container that this style is going to be connected to. We're going to have a container that our whole application is going to kind of fit inside of. To do that, I'd like you to open up the app RS file again for me, please. And what I'd like you to do for this one is I'd like you to come right above the app component here. And let's go ahead and create our first component together. So we'll put hashtag component, and then we're going to say pub function container, children, and we'll say this right here. And that needs some parentheses. Okay, so go ahead and add that. So what's going to happen here with this component? This component is going to be the container. It's going to wrap the rest of the layout of the page. Children represents all of that child content in the layout. The header, the footer, the main content, the sidebar, the menu bar, all that good stuff. All of that goes inside of our div class container. This is going to turn this or return a view, and this is our view macro that's going to generate a view from this content. Next thing I'd like you to do is once you've got the container there, I'd like you to come down to where we have the router. And down here in the router, I'd like you to type in container. And then go ahead and close the container like that. And then indent that for me. I'll pause for a second and let you wrap the container there around the router. Okay, now that we have our container wrapped around that, our next step is we need a page header. So what I'd like you to do is right below container here, let's add a new component. Go ahead and define us a page header. Now we're going to make a few modifications to this, but go ahead and add this for me. Also, for any of these individual functions for this part of the course, if you want to copy from Tools App Final, you can. You won't necessarily be able to do that for everything in the class because some things get complex, like you need parts of the code, but not all of the code. But for these individual little components like this, if you want to copy those from Tools App Final, you're more than welcome to do so. Okay, next step. On my page header here, I'd like you to modify this to say Tools App. Typically, in Leptos, you're going to wrap your string here in quotes. I'd like you to add to the header here an ID of page header. This is what our style sheet's going to be looking for. So go ahead and put page header in there for me. Okay, so there's our page header. If you scroll down a little bit down to the app component, we can actually come into our container here and put page header. So go ahead and put page header there inside the app component. So you can start to see here, building this is, at least for the easy part here, is pretty much just like working with React. It definitely feels more like React than it does Angular. Angular is a little bit more involved when it comes to its components, but React, this is really what this feels like. The same thing is true for like Svelte and stuff. It's a little more involved when it comes to its components. But React is all built around the idea of a component as a function. And you can see that's what we're designing here for our components. Thank you for posting the link. I'm sorry I missed the chat there. I apologize. Thank you for posting the link. Okay. Next step, let's go ahead and build a second component. This will be page footer. It's good to build up a little bit of muscle memory on the on these things here. So we have our copyright here, and let's do 2024, and then you can name the company whatever you'd like. So I'll say Training for Programmers LLC. There's our page footer, and then you can take your page footer and just come down here to the bottom, and we'll say page footer there. So go ahead and put your page footer there after the router. Okay. Now, we've gotten a little bit of muscle memory for typing out these components. The next component is a little bit long. So instead of us typing it out from scratch, what if we just copied and pasted a little bit of code? What do you think? So I'm going to go to Tools App Final. I'm going to go into the source folder, and I'm going to open up app.rs. In app.rs, you'll see there's a nav bar and a sidebar component. I'd like you to copy the sidebar and the nav bar. So just go under Tools App Final, go under the source folder, go to app.rs, and you'll see a nav bar and a sidebar. We'll save ourselves a little bit of typing. I'm going to copy this like that. And then I'm going to come back over to our Tools app that we're building, and right underneath page footer, I'm going to add these two. But what I'd like you to do is only keep the home link for right now. So in the nav bar, keep the home link. I'll pause for a second while you do that. And then we'll add those to our container, and then we'll work on our content component. Our goal is to be able to, we get to the end of the first session here in 10 minutes, is to be able to run this and see all the styling and stuff. And then when we come back, we're going to start working on our color tool application. And for some of the big parts, we'll do some more copying and pasting. Okay, so now that I've got my nav bar and my sidebar, we're going to come down to page header here, and we're going to say nav bar and sidebar. So go ahead, in fact, put the sidebar, if you could, after the router. Okay, I'll give you a moment to do that. The next thing we're going to do is build the final component for here, which is going to be the content component. And we're going to move the router into the content component. And once we do that, we'll be able to run this thing and make sure that everybody can get it up and running. All right, cool. So now we're going to add another component. We'll reinforce that muscle memory here a little bit. Component, public, function, content. And then what we're going to do is inside of here, we're going to take this whole router section, pull it out, and pop it down here inside of main. And in fact, what we can do is just put this ID on the main there. and we should be able to set it up just like that. So go ahead and build out that content by copying the router up into it. Make sure you put an ID on the main element. That way everything will output as expected. All right. Once you've got that done, down here between the nav bar and the sidebar, we're just going to put, whoops, we're going to put content just like this. On your title text here, you can say welcome to Tools app if you'd like. I'll pause for a moment, and then what we're going to do is we're going to recompile and run the application. Okay, I'm going to come back down, and I'm going to hit Control-C to stop. Then I'm going to do cargo Leptos serve. For those of you who are just joining us, we're not using the watch because the watch can be problematic. So each time we go to run this, we're using cargo Leptos serve to actually serve it up. So we'll go ahead and say cargo Leptos serve, and we'll run that. Okay, I'm going to click on open in browser, and it should look like this. The click me should still work, and your overall layout should look like that. It's not the world's best design. I'm not really a designer, but it'll make it feel a little more real as we add functionality to it. I'll give you 2 or 3 minutes to go ahead and finish building this out. While you do that, I'm going to say git checkout -b live demo, and then git add oops. So what I've done is I've set up a branch here called live demo. That will be the actual code that we code up together as a group as part of the class. So if you come back over to the repository here, you'll see there's now a live demo branch. With that live demo branch, you can now come into here and see the code that we are modifying in Tools app. So just go to the repo and select live demo if you want to copy any of the code that I push up from the demonstrations. So if you get a little bit behind or you get pulled into something else, I'll push up at reasonable intervals. I'll push the code up to the live demo branch, and you can copy and paste from there. Okay. Any questions from anybody so far? If you could put it in the Q&A, I'll give you a minute or two. Just kind of open it up to any questions anybody might have about anything we've talked about up to this point. Now, keep in mind, we're doing this as like a one-day session here with a large group, as opposed to, let's say, a professional classes are smaller, and in a professional class, you have your microphone turned on, and we have, verbal discussions and everything else. But for these free classes that I do, I kind of do them as more like an extended webinar. So keep in mind, if we were doing this as a truly smaller professional type class, we probably would go a little bit slower on some of these things and have more discussion. But for this, I want to get you as much as we can in the 6 hours. So we're moving at a pretty good clip. But if you've got a question or whatever, feel free to go ahead and ask it in the Q&A. All right, let's see here. This is running entirely client side. Yeah. Other than like an initial static rendering, the application here at the moment is running completely client side. Now, once we add in the database part of it, then you'll have server side stuff running. So bringing in something like Tailwind, I don't really have any real specific advice in terms of leveraging all of the, so like with things like Tailwind, you can have it kind of recompile itself so it only includes the parts and pieces of Tailwind that you want. I don't really have any specific advice on doing that specifically with Leptos. I know that if you look at the official Leptos documentation and go to the official examples, in the official examples, they actually have one that uses Tailwind. So if you take a look at those Leptos examples, so if we go to leptos.dev, my memory is correct. If we go to examples, there is a Tailwind. So we're using Actix, but you can also use Axum as your backend as well. And they have an example of using Tailwind. I would encourage you to look at that. Tailwind is fantastic. I've actually used it on real projects before, but I don't generally use Tailwind for the things that I'm doing. I just write my CSS. I'm not the world's best CSS programmer at all, but I do understand how it works. So I find it's just easier for me to kind of code up my own thing. But if you love using Tailwind, I know it's very popular. You can find some examples here, and I'll give you this one specifically to the Actix repo, which you can take a look at. Hopefully that'll be helpful to you. There you go. Okay, cool. So what we're going to do is we're going to take our break. When we come back from our break, we're going to take a look at how parent and child components can talk to each other. Now, ordinarily in a typical UI programming class, I wouldn't cover that topic till a little bit later in the course. But this is actually one of the areas where we start getting into some of the Rust aspects of programming that can be challenging. So I want to talk about some very specific demos on parent-child communication in the second session. And then when we get to the third and fourth sessions, we'll build out the color tool application, and maybe we'll talk some about car tool if we have time.